Bien, bonsoir, et maybe in English.
You
Is
can.
better?
You
Yeah.
have the choice.
So thank you for inviting me here, and I will just tell you a story of my company which named VPLP. I am the LP of the four letters, and VP is my partner, which is Van Petegem. And we have launched this company more than 30 years ago, and we never stop designing racing boats and racing materials for this time. And we are a company. We are just about between 15 and 20 engineers and your designers, and working on these fantastic boats. That's some examples we had, which America's Cup in 2010. Innovation was a big wing sail, 68 meters long, which was never done before. And after on the left, we have was a kind of model to try to combine foiling with a wing sail on small boats to adapt it on the Artemis Racing boat, which is competing the America's Club 35 in Bermuda at the moment. And the last slide is, I would say, this boat is going to be launched in 1 year and is being built by Group Beneteau, which is a quite famous yard for production boats. And it will be the first production boat which will be equipped by foil. So we definitely think that a new era is coming with foiling with all kind of boats. These are some boats which are ocean racing materials. Maybe you heard about these. They are all 100 feet long, and they are mostly single-handed, sometimes cruising, sometimes with crew. Sorry, not cruising. And they are designed to participate to a single-handed race in 2019, around the world without assistance and without stops. And this is going to be, as I say, super Vendée Globe, and this will be an amazing race. And these boats are the first ocean racing boats which are going to be equipped with foils, and we hope to be able to foil these boats most of the race. But with the waves, it's let's say it's another world. And if you can see foiling boats on flat water, something that we know how to do it. But when we have the waves, it's a completely different subject, and this is going to be really new for us and for the skippers. They are going to sail on it. And these are just for finish, just what we do in our company. We do some cruising boats, cruising catamarans, big cats, and we have some new design like gunboat. Anyways, that means that our activity is quite different, and we have lots of different projects on the table right now. So the subject is, the starting point was when 1997, around the world with a boat. The record was 71 days, and less than 15 days or 15 years after, 18 years after, we had a record which was beaten in 41 days, which means that when we were in 1997, we would have been half of the route to make the same distance as it has been done in 2015. So it's very massive improvement. It's about divided by 2 the time to run the world sailing. So what are the principal factors which could help to make the boat faster? Of course, at the early beginning, that's our job is the conception. And after the boat is being built in the yards and using some materials, and after we have to put some equipment on it to trim and to make the boat sailable. And at the end, I think we have the energy. The energy is important because these boats need energy to sail. And after we've got the human factor. Human factor is the people have to adapt themselves too, because sailing at 15 knots is not the same as sailing at 30 knots. And at the end, there is a big factor, which is all the techniques and what has to be improved to sail fast. Is mainly all the computer which are on board and all the new tools we have in terms of strategy, weather forecast, and so on. First of all, for the point number one, just an example. Originally, we had some test in a tank test. So what is a tank test? It's you take a model, you put it on a trolley with a balance, and you pull the trolley at different speed, and you record the drag of the hulls in different situations. And this allows us. It's quite demanding because we need to build some big models, and we have to make a lot of runs. And I mean, for a project, it means about 10 different hulls is already a big program. And now we have validate what we name the CFD, which is a computational fluid dynamic, which is exactly the same thing instead of being in a real, it's just numerized, which means that instead of having 10 models tested, you can have hundreds of models tested, and you get after some soft to classify them and to be able to like that we can it's a big help for investigation. And shapes of hull is the drag, and the drag is a performance. The more we can reduce the drag, of course, better the performance can do in the boat. So just a quick clin d'œil, as we say. We say that the boat which is on the left is about Eric Tabarly's boat in 1960, which was a boat which was 16 meters long, which was already a very big boat for single-handed. And why not bigger? Because technique couldn't allow the skipper to manage such bigger boats. And now, with all the advanced technology we have put on the boat, we can have a boat which is twice bigger, thanks to all the improvements we are going to make on the boat in terms of, for example, construction, aluminium and wood was the materials to build the boat in 20 years ago. And now, when you see the structure of fully carbon boat using aeronautic techniques like vacuum bag, curing, and high performance carbon fibers and so on, which give us some. I think we just divided by 2 the weight of the boat by improving the material and the process of fabrication. Another thing which had to be improved was the gears, the deck gears on boat, because small boat is a small effort, big boats is big effort, and it's obvious that now when you have a boat which is 100 foot long and 15 tons of displacement for one guy, we have some loads, for example, on the main sheet, which will be over 18 tons, and how to cope with 18 tons for trimming a sail. We've got some assistance like winches, pedestals, and even bicycle, and you can see that there has been a bicycle installed on the spindrift boat, and if you are fond of America's Cup now, you can see that the New Zealand Challenger have 4 bikers in the boat instead of having 4 grinders, and it looks like we are pretty much more powerful with the legs than with the arms. So that's the kind of thing we have to go to if we want to improve the performance of the boat. There is another thing which is quite important for these ocean racing boats is that I think my friend Conrad will speak about it better than me, because it's one of his hot topics, I think. But it's just that we came from a traditional production, transportation of storage of energy in the boat to something which is very much more modern, lighter, and more efficient. But thanks to Conrad to speak about all these things, it'll be quite better than me, I think. Maybe another one? No, this one. Of course, sailing a boat at low speed I was before was just like adventurers which had conventional oil skins to prevent them to be too wet. But now I think the boats are faster. The apparent wind is very much more important. Boats are much tiring. They are brutal, and so we need some specific equipment. I'm not sure Conrad has this equipment now, but I would imagine that by the time we will design some new boats, we'll have to be more careful about to be wounded on board, because the boats are not as comfortable, I would say, as it was before. It's 15 knots against 30, 35 knots, and the waves are the same, and the shocks are quite more important. Of course, it's a square of the speed. So there is. Sorry. Okay, want me to read it? And yeah, I like to see that too. And yeah, another thing which is quite important, and we'll see just after, is how to sail the boat, choose the route, and make the strategy. You can see Loïc Perron, when he was 3 years ago, he was on an oldies boat making the transatlantic alone, and he came back on the sextant and the paper charts and just very old-fashioned gears to make the navigation. And on the right, you can see the winner of the Vendée Globe, which is Armel Lecléache, which has a chart table which is much more like a jet table with we got tablets and got sorts of screens, got some alarms, and we can't see all the soft which are just behind to help him for navigation. And I think he spent a lot of time on his chart table to do the strategy with his new tools. So these guys became some electronics engineers by the same time. And just to show how we would have sailed before with a slow boat route. You got the shortest route. Shortest route is you go straight, and it appears that you don't choose your weather forecast. And if you have some strong wind in the nose, you have to have strong wind in the nose. And you just we didn't have all the device and all the tools to anticipate all that. And if you see, for example, the fast boat route, which is possible with all the weather predictions and all the polar diagrams of the boat and routage program and so on, you can see that the boat can avoid to be in the worst condition. And for example, when we designed a boat for Frank Camas, the idea was clear. We had discussion with his router, and he says, please bring me in areas where there is no more than 30 knots of winds and where there is no more than 3 meters of waves. We mean from our side, we could take this into account. Instead of having a very, very tough and heavy boat, we could have a lighter boat, faster boat. So he made a longer route, but at the end of it, the longer route was more efficient than the short and the hard route. And when you take the slow boat route, it's not a big, it's never a big gain, because it's where it's just there that you can have some avary, some breakage or things like that, you know. So that's where we are now, and we came now to a step where we had to make the junction with aeronautic engineers. And if you see just schematics shows a wake of hulls of catamarans, which are Archimedeans. And on the right, you will have some the wake, which is foil, and the wake is drag, and less drag, more speed. And thanks to meeting these aeronautic engineers, we will be able to go to a new generation of boat, where we can adapt on the boat the technology we have on a plane, and the plane being a fly-by-wire concept, and we are going to be on a foil-by-wire concept by working together on a new projects, by using wing sails, and wing sails which are the best efficient sail to have the better ratio performance to surface areas. And the thing which was prohibiting with the wing sail is we were not able to reduce the area of the sails, but now we have developed with my partner VP from Petegem a new sail which is named Ocean Wings, where we can adapt the surface of the sail to the weather conditions. So I think that's the next project we are going to work on, is and that's the key of beating records today, will be to fly the boat as much as possible. And I think if I could have a little video, Mariana, maybe? No? Which is just the VPLP and Airbus collaboration presentation. So that's where we are now, and hope we will be able to come to the reality and not virtual. And but definitely, next boats are going to fly. They already fly in Bermuda in flat waters, but they are going to fly in heavy water too.